Hello students, welcome to a new session. Today we are going to solve the numericals given in exercise 4A of your Concise physics textbook. In fact, these numericals are very simple to solve provided you know all the formulas of that particular chapter. Anyway, let's solve these numericals recollecting all the formulas. Here we go. We start with question number 1. The speed of light in air is 3 into 10 to the power 8 meter per second. Calculate the speed of light in glass. The refractive index of glass is 1.5. Question number 1. The speed of light in air is 3 into 10 to the power 8 meter per second. All of you know the formula or the relationship between refractive index and speed of light in a given medium. So the refractive index of a given medium can be expressed as the ratio between speed of light in air and the speed of light in the given medium V. Okay, so the refractive index of the glass mu g is given as 1.5 and the speed of light in air is given as 3 into 10 to the power 8 meter per second, and the speed of light in glass Vg you have to calculate here, that is unknown quantity. Now let's place the values given in the respective formula. So remember the formula, the refractive index can be defined as the ratio between speed of light in air and the speed of light in given medium. Okay, the refractive index of the glass is given as 1.5, that's equal to speed of light in air is 3 into 10 to the power 8 meter per second, and the speed of light in glass is unknown quantity, let it be Vg. Okay, therefore Vg is equal to 3 into 10 to the power 8 meter per second divided by 1.5. So solving it, we get it as the speed of light in glass Vg is equal to 2 into 10 to the power 8 meter per second. I hope the steps are clear to you. Once you know the formula, you can easily solve this type of numericals. Now moving on to question number 2. Look at the screen. Let's read the question and understand first. The speed of light in diamond is 125,000 km per second. What is the refractive index? Speed of light in air is 3 into 10 to the power 8 meter per second. So we have to calculate the refractive index of the given medium, that is diamond. So we know the relationship between refractive index and speed of light in given medium. So the refractive index of diamond mu d is defined as the ratio between speed of light in air C to the speed of light in given medium, that is Vd, speed of light in diamond. Now let us see what all quantities are given there. The refractive index of the diamond we have to calculate. Speed of light in air is given, C is equal to 3 into 10 to the power 8 meter per second, and speed of light in diamond is given as 125,000 kilometer per second. Look at this quantity. So we have to convert kilometer per second into meter per second. So I can write it as 125 into 10 to the power 3. 10 to the power 3 kilometer per second. So convert into meter per second, just multiply it by again 1000. Okay, 10 to the power 3. Clear? So it comes out to be 125 into 10 to the power 3 into 10 to the power 3, that is 10 to the power 6 meter per second. Now kilometer per second is converted into meter per second. So don't forget to convert kilometer per second into meter per second. Clear? Now let's place the values, given values in the formula. Okay, refractive index of the diamond we have to calculate. Mu d is equal to 3 into 10 to the power 8 meter per second. That's the speed of light in air divided by speed of light in the given medium, that is 125 into 10 to the power 6 meter per second. On solving it, we get it as, solve it by, and we get it as 2.4. So refractive, remember that refractive index has no unit, it's a pure ratio. So the refractive index of the diamond is 2.4. Clear? Steps are clear to you? Okay. Now let's solve question number 3. Look at the screen and read the questions. The refractive index of water with respect to air is 4/3. What is the refractive index of air with respect to water? So the refractive index of water with respect to air, refractive index of, how it is written? Refractive index of water with respect to air is given as 4/3. Clear? We have to calculate refractive index of air with respect to water. So what is its value? That we have to calculate over here. So we know the formula when refractive index of water with respect to air is given. So what is the refractive index of air with respect to water? Very simple. Reciprocal of 1 by refractive index of water with respect to air. Clear? Just take the reciprocal of the given quantity. So I can write refractive index of air with respect to water is equal to, it is given 4/3. The reciprocal of that, just reverse is 3/4. That's equal to 0.75. Clear? So remember, refractive index has no unit since it is a pure ratio. Clear? So this is the key point here. Once again, if the refractive index of water with respect to air is 4/3, what is the refractive index of air with respect to water? Take the reciprocal of the given quantity. Clear? Very simple. Now moving on to the last numericals of exercise 4A. A ray of light of wavelength 5400 angstrom unit suffers refraction from air to glass. Taking refractive index of glass 3/2, find the wavelength of light in glass. So here we have to find out the wavelength of light in glass. The refractive index of the glass is given as 3/2. Clear? So what you have to find out? The wavelength of light in glass. Now remember the relationship between refractive index and wavelength of the light. So refractive index of a given medium can be expressed in terms of wavelength of the light as the wavelength of light in air lambda divided by wavelength of light in the given medium, that is glass. So remember, the refractive index also can be expressed as the ratio between wavelength of light in air and the wavelength of light in given medium. Here in our case the medium is glass, so I have taken lambda g. Clear? Now what is quantity is given there? A ray of light of wavelength 5000 angstrom unit. So the wavelength of light in air given as 5400 angstrom unit. Clear? So lambda g we have to find out, wavelength of light in glass we have to find out here. Now let's place the values given in the formula. Refractive index of the glass is given as 3/2. That's equal to wavelength of the light in air, that is 5400 angstrom unit divided by lambda g. Clear? Therefore we can calculate lambda g, the wavelength of light in glass, as 5400 angstrom unit divided by 3/2. So that's equal to 5400 into 2 divided by 3. So that is 1800 into 2, that's equal to 3600 angstrom unit. So this is the wavelength of light in glass. Clear? I hope the steps are clear to you. So once you remember the formula, you can again solve the numericals very easily. So what is the key formula here? The refractive index in terms of wavelength of the light. So refractive index can be defined as the ratio between wavelength of light in air and the wavelength of light in given medium. Clear? Yes, that's all for today. Have a nice day.